Good morning to all. So, in this session, myself, S.Tamil Selvi, belongs to the Electrical Electronics Engineering Department of Erode Engineering College. In this session, we're going to discuss about the nodal analysis for the scheme of preparing SC/ST students for higher education, that is means of an GATE examination. It is under the AICTE Prerana. In this session, we're going to discuss about the nodal analysis. In the last session, we just discussed about the mesh analysis, and before that, we just discussed about the network elements. In that network elements itself, we discuss about the what is mesh, loop, and nodal, etc. Like that. Okay, so based on that, we know that mesh, which is nothing as an, it is also formed as a closed path of all the branches. If one branch is open means it does not form a closed path. That kind of network is called as a mesh. The same thing as a loop, but the one simple difference is a mesh does not contain loop, but a loop, if it under the nodal analysis, we can that is a one of more than two or three branches meet at a point that can be seen as in a nodal. So in this node, we're going to discuss about the voltage. Going to analyze about the voltage. Okay, so that is in a circuit. We're going to discuss and analyze the only the voltages. Primarily, we're going to concentrate on to finding the voltage in a circuit. So that is this analysis can stay as in a node voltage method. Okay, so in nodal analysis, we're going to consider the one on the node voltages with respect to the ground. So with respect to the ground only, we're going to determine the node voltage. Hence, that nodal analysis is called as in a node voltage method. So the simple procedures we're going to follow in the method, that is, in first step, we're going to first, if they're giving a circuit, if they're given a circuit, in that circuit, we're going to first identifying the number of nodes. So what is mean by node? We know well a node which uh, three or more than three branches meet at a point, two or more than two, or two or three branches. We may consider like that. So more than three branches meet at a point is called as a node, right? So that node will have to be found. Okay, that kind of nodes. What are the number of nodes are present in the circuit? So that we have to identify that. So identifying the principal nodes and choose one of them as a reference node. In that n number of nodes, we have to choose one as a reference node. That reference node will be as a grounded node. Okay, we have to treat that reference node as a ground node. So see in this circuit. So here the circuit given here is the node is three or more than three branches meet at a point is called as an node. So totally we are having the three nodes here. See, this is a one node and this is another node and this will be another node. So totally we are having three nodes. In these three nodes, these three nodes are the principal nodes. In the principal nodes, we have to choose one as a reference node. So that one node will be act as a ground, right? Will be have to treat as a ground. So which node will be considered here as a ground? So this node, either this or this. We can't able to consider this will be act as a ground because the supply is giving inside, going towards the point. So this will can't able to treat as an ground, as well as here may be a chance, but see here the current direction is towards this node also. So this node will also can't able to treat as an ground. So this is a node which can able to treat as an ground, right? So this will be considered as a reference node here. So that will be given. In the first point, we have to identify the principal nodes and then choose one of them as a reference node, and that reference node will act as a ground here. And let's see the second step. In the second step, you have to label the node voltages with respect to ground. You have to note the node voltages with respect to ground from all the principal nodes except the reference node, right? So this is a ground. Except this, with respect of this node, we have to point the nodes, right? That is V1 and V2. Here, V1 and V2 here. We just label the name V1 and V2. Then, with nodal equations at all the principal nodes except the reference node, nodal equation is obtained by applying KCL first and then apply the Ohm's law. So can you clear with this statement? Write nodal equations at all the principal nodes except the reference node. Okay. Then nodal equation is obtained by applying KCL law and then Ohm's law. See here, except this reference node, we having the two nodes V1 and V2. We have to apply the KCL law in this V1. Then that equation will be changed by applying the Ohm's law. Similarly, like you can apply the KCL law at this node V2 and then change that into by applying Ohm's law, then we have to change the equation there, right? So totally we have to only forming a two equations in this node, right? Then solve the nodal equation obtained in step 3 in order to get the node voltage. Then the fourth step we have to solve that equations. You have to solve the nodal equations either by using equation solving method or by using a matrix, that is by Karna's rule method. Okay, so Karna's rule method is very easier when compared to equation solving. If we having the two variables of only two variables of equations, that is here we having the two variables, that is v1 and v2 is the two variables. Based on this we just forming the only two equation. In this case we can solve the equation very easily. So if the question will be changed, if we having the more than two, if they're forming a three nodal equations, we better to go for an a matrix form. So that is very easier to determining the del v1, del v2 like that. So it is very easier as like in a mesh analysis. So better choose an a matrix form. For this also it is very easy 2 cross 2 matrix. So you may use matrix or may use equation solving method, that is a simultaneous equation method, right? So this is a procedure which we're going to follow in this nodal analysis. So first listen, once again I just repeat. First step, you have to mark a node. Okay, how many nodes are present in your circuit? That we have to mark it out. In that circuit, you have to take one as a reference node. That reference node will act as a ground here, so that your principal nodes, the principal nodes are three nodes. In case if three nodes are present as a principal node, then one should be considered as a reference node. And next, no, we have to unknown node is in only two nodes. Two unknown voltage node is present there. Okay, and next, after choosing the reference node, you have to give the name for the another nodes, another remaining nodes. So with respect to a ground, then applying the nodal equations by using a KCL law and Ohm's law. So if we have to implement the KCL law, means we know what is KCL law. That is Kirchhoff's current law. Kirchhoff's current law. What is the thing which what is the statement behind the KCL law means? The sum of the current flowing towards the junction is equal to the sum of the current flowing away from the junction. There is this junction point there, right? So for that junction point, the current going inside the point is equal to the current away from the point is a one statement. In another statement, we can also express the algebraic sum of the current flowing at the junction point is equal to 0, because the current entry is equal to current out, right? So at the junction, there is a no current. The sum of the current is equal to 0 at junction. So that's KCL law. So but you have to apply that, right? Where current direction, there is I1, I2, I3 is that. So in which direction the current is entered in that point or leave at that point. Based on that only we have to form a KCL. So for that you have to assign the branch current, right? You have to assign the branch current. Then we can write the KCL law and then you can apply Ohm's law. Okay, and then only we can solve the equation by solving method. Okay, so this is a procedure which you have to follow in to determining the nodal voltage. So this is a problem, sample problem, which we're going to solve. Calculate the node voltages in the following circuit. So see, this is a circuit which we given. In this circuit, we have to calculate the node voltages. So first you have to assign the node voltage as V1 and V2. And the current flowing towards the junction is I1 and I3. And the current flowing away from the junction is I2 and I3. So based on this equation, we're going to apply the if they didn't give any if they didn't give any branch currents and if they didn't give any current sources, then you just convert the current voltage source into current source. In the circuit, if they give only the voltage source means you just convert that into current sources, right? That's here in the question itself, they just given here as a current source. If they give us a voltage source means for finding the node voltage, you must to convert the voltage source into current source. Then only we can assign the current direction. Okay. So here the current directions are all given, right? Assign the node voltage as V1 and V2 and also mark the direction of branch currents with respect to your reference node here. So first you have to assign the nodes. In this case, your nodes are V1 and V2 is nodes, two nodes, and this node will be considered as a reference node here, right? So this will be considered as a reference node. And two nodes V1 and V2 are given that will be labeled as V1 and V2. And also we just mark already in question itself they just given as a branch currents with respect to the reference nodes, right? So based on this equation, we're going to apply the step 2. In step 2, we have to apply the KCL law at node 1 and node 2. See, so this is node 1. In this node 1, you just apply the KCL law. In KCL law, in KCL law, the sum of the current flowing towards the junction is equal to the sum of the current flowing away from the junction. So the current flowing towards the junction, this is a junction point. The current flowing towards the junction is I1 and I3. And the current flowing away from the junction is I2. And which is equal to the sum of the right sum of the current flowing away from the junction. So towards the junction is I1 and away from the junction is I2, I3. So this equation will be written as I1 equal to I2 plus I3, right? So same point in when you are applying the KCL law at V2, see here the current flowing towards the junction is I4 and towards the junction I2, away from the junction is I5 and I1, right? So based on this, you just write the equation C. I1 equal to I2 plus I3, and at node 2 I2 plus I4 and I1 plus I5. Okay, these are the two equation we just noted with by applying the KCL law. Right. So next, after forming the equation based on KCL law, you just apply the Ohm's law into the KCL law. We know that what's Ohm's law? Ohm's law is where V is equal to IR, right? And where I is equal to V by R, right? So V is equal to IR, I equal to V by R. So the equation of KCL at node 1 is I1 is equal to I2 plus I3. So which is equate, convert that into V by R. That is I is equal to V by R based on that. So where I1 equal to I2, I3. We know the value of I1, right? I1 is a current that is 5 ampere. See, I1 is 5 ampere. And we don't know I2, I3 and I5 also, where I4 is a current flowing towards that value is 10 amps. So we know the only two values, one is I1, another one is I4. We don't know the current value of I2, I3, I5, right? So for that, you just apply the KCL between the potentials. Okay. So see, I1 is 5, I2 plus I3, I2 is so V1 minus I2 is a current which flowing in between the nodes V1 and V2. So V1 minus V2 to the resistance 4 ohm resistance, right? This is a 4 ohm resistance. That is V1 minus V2 divided by 4. Same I3. I3 is a current which flowing in between V1 and this is a reference node. In between this only the I3 current is flowing. So this will be written V1 minus 0 volt divided by R value is 2. Simplifying this above equation, you can get 3V1 minus V2 equal to 20. So now let's again you just apply the Ohm's law to the KCL equation at node 2. Right, at node 2. So in this equation where I2 plus I4 which is equal to I1 plus I5. We know the value of I1, I4, but we don't know the value of I2 and I5, right? So I2 can written I2 can be written here in between V1 minus V2. But now we have to going to consider this point. So V2 minus I2 is equal to V1 minus V2 divided by 4 plus I4 value is 10 and I1 value is 5 plus your I5 can be written here. See, I5 is a current in between V2 and 0 potential. So that's why V2 minus 0 divided by 6. Right? So you just simplifying this equation, you can get minus 3V1 plus 5V2 equal to 60. This is equation number 4. So now let's, by using an equation solving method, you make 3V1 minus V2 equal to 20 and minus 3V1 plus 5V2 is equal to 60. So can you, if you solve this equation, 4V2 is equal to 80 and where V2 is equal to 20 volts. Now let's you just substitute the value of V2 is equal to 20 volts in this equation, then you can get 3V1 minus 20 equal to 20. Let V1 equal to 40 by 3, 13.33 volt. So let's, the node voltage are V1 is 13.33 volts and V2 is 20 volts. So this is a simple node analysis problem. So like this way only they ask if the circuit is given here, the circuit which gives a directly a current source. If they doesn't give any current source here, they just only give that voltage source, then you have to convert that voltage into current source by source transformation, right? Just changing the source transformation method, you just convert that current voltage source into current source. So by using that only, the nodal analysis with an current source form we can apply, right? So the applications of the nodal analysis is mainly used to determine the voltage. Based on that, we can determine the power. Okay, so this can apply for both AC and DC analysis. This is a nodal analysis. So this is a sample problem, right? So this is a sample problem which we discussed in the nodal analysis. Let's we just discuss in the next class of next problems. Okay, thank you, thank you.